I'd like to invite Jussi Heinonsalo back on the stage and also invite Professor Matthias Rillig back for a little discussion on screen. Hello, Matthias. Welcome back. So, again, dear audience, we have some very good questions already from the chat, but you still might have a chance to get yours in, so now's the time. And I'd like to ask all of you, first, a sort of a communications-related question. How should we talk about soil biodiversity to wider audiences in order to get the general public to understand its importance as a tool for our well-being as humanity? Could Professor Rillig perhaps go first?
Sure. Yeah, thanks. This is a great question, really, and it's one that we've been asking ourselves a lot. I'm not sure I can give you the perfect answer, but the problem is that soil biodiversity is not inherently charismatic. I don't know how many of you have pictures of soil animals or soil fungi on your wall, or how many of you have a stuffed animal of some soil organism on your sofa. So they're not immediately accessible to our senses because they're so small, we can't really see them, they don't sing beautiful songs, so we can't listen to them, they are not cuddly. And so I think there's three things you can do. You can adopt a more utilitarian perspective and argue that argue about all the services that soil biodiversity makes happen for us, like in terms of plant growth promotion or in terms of decomposition. We've heard in the talk from Franziska about this. This is liberating nutrients, and this is where our food comes from in the end. This is good. Another approach is maybe you could call it shock and awe. So hit people with some amazing numbers and say, did you know that there's more bacteria in a handful of soil than humans that have ever lived on this planet? Or can you imagine that there's 50 meters of hyphae of mycorrhizal fungi in your grassland soil? How does it even fit in there? It's just because it's so tiny. But I think what's also important is to somehow elicit an emotional response and instill a sense of wonder, because I think only if you have really some sort of an emotional response can you get people convinced to conserve this diversity that is so removed from our senses. And so this is why in our lab we've also worked with artists that can help bring out the beauty of these organisms, and it can also help people relate to the complex habitat that soil biodiversity inhabits. But it is a huge challenge, and if you do one of these three things, I think it could definitely help.
Thank you. Shock and awe, that's certainly a tried and true technique. Jussi Heinonsalo, what do you think about how we should be talking about soil biodiversity?
Well, I completely agree what Matthias said before, that it's a big challenge. And I think it's maybe good to talk about biodiversity as such in general, not only soil as a speciality. We know that, all biodiversity is important, and it's very difficult there also to say that why a certain bird or a certain insect would be so important. I think in soil, okay, we don't have these fancy species that are kind of easy to advertise, but I think it's kind of philosophical question that diversity is important, and we know that it supports all the important functions. So maybe indirectly we can promote that biodiversity, soil diversity is important because of many uses for humanity. But it's a difficult question.
Good strategy. Anna-Liisa, would you like to add something to this?
Well, I think the points raised by Matthias and Jussi were already excellent, and I think I can just add on top of that I think we should be talking about soil as a living organism. I think too often we think about it as a substrate that we can simply manipulate and pump nutrients into that, and we're really concerned about the plants. But if we think about soil as a living organism, if we don't treat it well, it's going to suffer, and if we nurture it, it will flourish. And I think it's a concept shift that needs to take place.
What a very intelligent way of thinking about it. I felt shivers go down my spine when I thought about that. Thank you so much. Let's go to the chat. We have a few questions, mainly for Professor Rillig, but also I think to Jussi and Anna-Liisa. And I think I'll start with the first one that we got. So, Professor Rillig, how to collect and measure plant root exudates and their interaction with soil microbes in the rhizosphere? And maybe in order to know and decide whether a given plant species had a positive effect for soil health or not. And this comes from Mulugeta Aitenev, who would like to know the answer of how to collect and measure plant root exudates and their interaction.
I think that was a question for Franziska, maybe.
Ah.
Right.
That might be.
I mean, we don't collect
well.
plant root exudates, and I think she's already beautifully described it in her answer, so there's nothing to add to that.
Hopefully Franziska is still in the chat, possibly. Let's see. And we have a few more for you, so don't worry. Definitely for you. This comes from Chris Holtzlag. He'd like to know, because you mentioned that Basidium mycota, meaning higher mushrooms, suffered the most. And besides fungicide, what factor was the most important contributor to their decline? And Chris Holtzlag assuming that tillage or digging would be another major factor to take into account.
Yeah, I agree that tillage and disturbance would be another factor to take into account. Of course, that was sort of only a condition in our experiment with these little tubes. So the soil was basically disturbed the moment you put it in the tube. So it was just a condition, and that did not lead to the decline of Basidium mycota in our experiment. Yeah, this is a good question. It's we also want to know what led in the end to the decline of Basidium mycota and also to the loss of functionality. But we cannot use this design to answer this question, right? Because we cannot pinpoint any of these responses to any one individual factor, because this was not replicated. What was replicated was the number of factors, not individual factors. And none of the individual factors taken by themselves, which we have separately replicated in this design and the future designs that we're currently working on, led to this decline. So it was really an unknown level of interaction among these many factors that we had in the experiment that led to this decline.
Thank you. And another one to Professor Rillig, and this comes from Tura Råberg. In Sweden, microplastics below a certain size are allowed to be added to agricultural soils. Can this be avoided by more thorough filtration and pyrolysis, aka producing biochar of the solid fraction after digestion? And what are your experiences from adding biochar to the soils?
Oh, wow. That is a very specific question. So I don't know anybody who has made biochar out of plastic. I'm sure you could. You could just prevent it from completely being burned off and just make char out of it. We have been thinking about this, but we haven't done this yet. And I don't know of anybody who has, so I really can't give an answer to this question. I can comment on the first part of that question. It seems like a bad idea to knowingly add microplastic or plastic to agricultural fields, because we have no idea how long it takes for this material to decompose. So for all intents and purposes, you add the stuff and it's going to be there for a very long time. We don't actually know the turnover time of microplastic in the environment. But the idea is that it's probably many decades or maybe hundreds of years. So you're doing something that is potentially irreversible. And that seems like a bad idea. Yeah. But to that other question with biochar addition, I mean, there's a whole huge body of literature on biochar that shows that in very many situations, this is a beneficial addition to soil, because it changes a whole lot of parameters in soils for the positive. And of course, it is itself carbon, so it leads directly to a greater amount of carbon in the soil. It also helps soil biodiversity. It helps ameliorate certain physicochemical parameters like cation exchange capacity. It ameliorates pH, and it increases water holding capacity. So the benefits are actually quite well known. But how that would actually work with microplastic-derived biochar, I don't know.
Interesting ideas, at least. Now we have a question for Anna-Liisa, Laine, or Jussi Heinonsalo, perhaps both of you. Is it possible to recommend a specified above-ground cover to maintain soil biodiversity? And how could you see the sensitivity of soil organisms for a slight change in climate, edaphic factor, or other management activities? So which specified above-ground cover would be good to maintaining biodiversity?
Okay, I think from our experiment, it's a little bit too early to say anything conclusive. It's still very much going on. But we do see big differences among the underzone species in how the ecosystem is responding to them. Currently, we see that perhaps the grass species are providing the least benefits. So clovers in our system seem to be very efficient, but the exact ratio of their cover and species, I think, will ultimately be a fairly system-specific choice.
Yes, that's true. And I think the first important thing is to increase plant diversity as much as is possible regarding considering the agricultural practices. So as Anna-Liisa showed in the early results already, that already one species can have positive impact. So maybe the first take-home message, as many as possible. And then the plant species that are most suitable, then comes certainly the question which soil type, which other conditions, how well they survive, for instance, Finnish winter. That's one question, that our cover crops, they have to survive the winter to be able to be active in photosynthesis in the spring, etc. So there will be many factors, but we will know more from our experiments in the near future. But the more the better regarding plant diversity, I would say. That supports the below ground diversity as well.
It will be exciting to hear more about your results.